Hi everyone, and welcome to Geometry Lesson 3.3, Proving Lines Parallel. In this video, we're going to talk about the different theorems that we use to prove lines parallel, and how to write a basic proof showing that two lines are parallel. So let's start by looking at the theorems. Now, if you did Lesson 3.2, these theorems should sound very similar to the theorems from 3.2. All we've done is we've used the converse of the theorem. So notice the order of the information that you know versus the information that you conclude really matters. Take a look at the converse of the corresponding angles postulate. It says if the corresponding angles are congruent, then the lines are parallel. So in this one, we know that we have corresponding angles and we know that they're congruent, so we can say that the lines are parallel. The regular corresponding angles postulate switched the order. We had to know the lines were parallel, then we could say that corresponding angles are congruent. And that's true for all of these. For our converse of the alternate interior angles theorem, it says if the alternate interior angles are congruent, then the lines are parallel. Converse of the alternate exterior angles theorem says if the alternate exterior angles are congruent, then the lines are parallel. And finally, the converse of the same side interior angles theorem says if the same side interior angles are supplementary, then the lines are parallel. So the basic idea of using these theorems is to say what kind of angles you have, say what you know about the angles, then you can conclude that the lines are parallel by naming one of these theorems. So let's take a look at the steps to writing an explanation as to why lines are parallel. Okay, so the steps are very basic. You have to show that the beginning of that statement from your theorem is true. So that's identifying the type of angle pair you have and then telling what's true about them, whether they're supplementary or whether they're congruent. Then finally, you're going to state the theorem or postulate that says that the lines are parallel. And that's always going to be a converse theorem. It's always going to say converse of. And it's always named after the type of angles that you identified in step 1. So you're always going to say converse of, and then name the angle pair and write the word theorem or postulate at the end. Okay, so let's take a look at some examples of doing this. In example 1a, it says show that line L is parallel to line M. And they've told us that angle 1 is congruent to angle 5. So we're going to start off by identifying the type of angle pair that 1 and 5 make. Notice angle 1 is to the left of the transversal and above the line that we think might be parallel. And angle 5 is also to the left of the transversal and above the line that we think might be parallel. So they're both in the same general position, making them corresponding angles. And we happen to know that they're congruent, so I can use the converse of the corresponding angles postulate to say that these two lines are parallel. And if I wanted to write it out, it would look like this. Angle 1 and 5 are corresponding angles, and they are congruent. So, by the converse of the corresponding angles postulate, L is parallel to M. Let's take a look at another example. In this one, they're going to make it a little bit harder. In example 1b, it says show that L is parallel to M. And they told us these values. Angle 4 is 2x plus 10 degrees, and angle 8 is 3x minus 55 degrees. Now notice they also told us what x is. So again, we're going to start off by identifying our angle pair. Angle 4 is here, and angle 8 is here, making them corresponding angles. Now, we don't know their measurements, but we do know that they should be congruent. We can take our 65 and plug it into each of these expressions to see what those measurements are. Now, you always have to show your work for this so that somebody reading your explanation will know how you got your numbers. So let me show you the work that I did. So for angle 4, I did 2 times 65 plus 10, which got me 140 degrees. And then for angle 8, I did 3 times 65 minus 55, which is also 140 degrees. So that means that angle 4 and angle 8 are congruent. So let me show you the final write-up for my reason as to why those lines are parallel. Angle 4 and angle 8 are both 140 degrees, so they are congruent. They are corresponding angles and are congruent, so L is parallel to M by the converse of the corresponding angles postulate. So let's take a look at another example, something similar to this one, but we're going to use one of the other theorems or postulates. In example 2, it asks us to show that line R is parallel to line S, and they've given us two different scenarios. In the first one, they told us angle 2 is congruent to angle 6, and in the second one, they said the measure of angle 6 is 6x plus 18, the measure of angle 7 is 9x plus 12. They told us x is 10. So why don't you pause the video and try those two examples, and then hit play to see if you're right. So angle 2 and angle 6 are alternate interior angles, and they're congruent. So I can say that R is parallel to S by the converse of the alternate interior angles theorem. Now for angle 6 and 7, what I did is I put in 10, and I got angle 6 is 78 degrees, and angle 7 is 102 degrees. Now notice they're not congruent, but 6 and 7 are same side interior angles. They're supposed to be supplementary, because remember, same side supplementary, all the S's go together. So if I add 78 and 102, I get 180, which means they are supplementary. So angles 6 and 7 are same side interior angles, and they are supplementary. So by the converse of the same side interior angles theorem, line R is parallel to line S. Now we have one more example. It's a proof, so we're going to use these theorems in a proof. In example 3, they asked us to prove that R is parallel to P. So that's this line here and this line here. And they've given that L is parallel to M. So this line is parallel to this line. They've also told us that angle 1 is congruent to angle 3. So what we do in our proof is we write our given statement. Now we know that L and M are parallel. So any of those theorems from lesson 2 are allowed to be used because we know that L and M are parallel. And notice that they've labeled angle 1 and angle 2. So it would be a good idea to decide what kind of angles they are and what we know about them. So they are corresponding angles because they're both to the left of the parallel lines and above the transversal P. They're corresponding angles, so that means that they're congruent. So that's where I'm going next. Angle 1 is congruent to angle 2 because of the corresponding angles postulate. Notice the order of the information. I knew the lines were parallel, so I concluded that the angles are congruent. Different order than what we've been doing in this lesson. Now, I noticed also that angle 1 is congruent to angle 3. So I decided to use the transitive property to say that angle 2 is congruent to angle 3. So that's the transitive property of congruence. Now, 2 and 3 is a different angle pair right here. They're alternate exterior angles, and if they are congruent, then I would know that this line is parallel to this line by the converse of the alternate exterior angles theorem. And that's how I finished my proof. Notice this last step is always what they asked us to prove. This is one of the theorems we've been practicing in this lesson. So I hope that was helpful. Let me know if you have any questions.